Hi everyone, my name is Hanxin, currently the fifth year PhD student of Rogers Business School. Today I'm very happy to share this project with you, which is called Application of Outlier Detection Methods in Audit Analytics. Basically, I work this project with my Rogers colleagues and some other partners from practice. In this project, we'll try to explore the probability of using outlier detection methods in audit practice, and this is the agenda of this presentation. Firstly, I'll show you some reasons and motivations why we can apply the outlier detection methods in auditing. Second, I'll give you a very brief introduction about popular outlier detection algorithms we have identified in the prior literature. But I will not show you very complex statistical or the mathematical mechanisms behind those methods. I just show you some intuitions behind them. Next, even though the prospect of using those methods in audit analytics is really promising, definitely there are certain challenges, and I will try to briefly discuss them in this presentation. And finally, I show you the proposed framework and evaluation results according to a case study. Okay, now we're getting to the first part of this presentation. I know that some of our audience may be not very familiar with these two concepts, the outliers and outlier detection methods. So I just try to give you a very brief introduction. As for the outlier, this is a kind of observation or data point which deviates so much from other normal observations, and we consider those data points really suspicious since they may be generated from a different mechanism. As for the outlier detection methods, actually they are not new thing. They were firstly proposed like 40 years ago. At that time, you can see that there are some non-G-based it's working now. We can see that there are some non-G-based decision systems that were incorporated with statistical models and matrix, and we can use it. Not working. To detect the information system security infractions. Now we have some basic understandings about outliers and the corresponding methods. In this slide, summarize three important motivations why we can use those methods as audit analytics. Firstly, after performing a very comprehensive literature review, we realized that such kind of methods are really commonly used in other domains and related areas. For example, outlier detection algorithms can be used to identify unauthorized access to computer networks. And secondly, we also realize that according to the classic outlier definition we just discussed in the previous slide, the outlier definition is thematically close to audit exception conceptually. Well, in the audit exception, basically they may contain some suspicious features such as abnormal debit, credit amount, suspicious occurrence time, and counterparties. Those kind of features make suspicious transactions a little bit different from normal ones. And this is the second motivation why we can use audit analytics, why we can use outlier detection methods as audit analytics. And third motivation is really important since we realize that it just has very minimal requirements of prior expert knowledge if you try to use outlier detection methods in auditing domains. It's well known that most of the outlier detection methods are unsupervised learning based. In this sense, they do not require the guidance of predefined labels. So that can really save auditors several time and efforts, and they don't need to label the transactions one by one. And on the other hand, compared to some expert systems like the math framework, the outlier detection systems usually require no prior knowledge to prioritize the suspicious risk. Okay, we have understand that it's really promising to apply these methods in the audit domains. In this slide, I just try to show you several introduction of popular algorithms in these domains. we have performed a very comprehensive examination of prior literature, especially in the computer science domains. And we have identified 6 popular types of outlier detection algorithms, such as the statistic-based, the distance-based, density-based, clustering, deep learning, and ensemble-based. You can just tell from their names, different algorithms are constructed based on different statistical or the mathematical mechanisms. In this sense, this kind of algorithms may generate different outlier detection results. These are 2 caveats you should take away if you try to use those methods in your analytics. The first caveat is that instead of directly outputting like the binary labels outlier versus the normal classes, the outlier detection methods only output outlier scores, and larger outlier scores indicate a high likelihood of being outlier. In this sense, the users should choose the cutoff and flag any risky data points with outlier scores above the established cutoff, and they can do some further investigation surrounding them. And the second caveat, sorry? Okay. And second caveat is that different algorithms may generate different outlier detection results. Just like we have discussed in this slide, the different methods are constructed based on the different intuitions. So it's easy to understand that the different methods can generate different results, and the users should exercise severe caution when choosing the outlier detection techniques. They should consider the specific audit judgments and audit objectives and try to select the appropriate methods. Even though the use of the outlier detection methods as audit analytics is really promising, there are certain challenges do exist. The first challenge is about the algorithm selection. Well, intuitively, the different algorithms are specialized for the different characteristics of the data sets. For example, some of the algorithms may have very bad performance in a high-dimensional data sets. And also, the outlier detection results may be affected by the different parameter settings. And the second challenge is about the understandability. We all know that machine learning algorithms are typically subject to the criticism of black box, and this situation is also true for the outlier detection methods. It's really difficult to understand which kind of attributes contributing to observations being outlier. And it's also very challenging for the auditors to document outlier detection results as audit evidence. And the third challenge there is about evaluation. We know that if you try to develop supervised learning methods such as a decision tree and regressions, you have the outcomes and you can use the cross-validation to tune the parameters and evaluate the performance of the method. But when it comes to the outlier detection method, it's not true, since you do not have the predefined labels, and it's really impractical to determine the false negative errors and the false positive errors. In this project, we'll try to partially mitigate the challenges a little bit. We are not so confident to say that we have overcome all the challenges. Well, in this proposed framework, initially, we obtained some data from our audit collaborators, and this data is the transaction data. And next, we did some pre-processing, such as the data cleaning, attribute engineering, and data normalization. And the purpose of this step is try to develop some valuable and useful features that can try to identify whether the transaction entry is suspicious or not. In this project, the features may include the credit or the debit amount, the transaction weekdays, the transaction counterparty identities, and so on. And next, we identify several popular and powerful outlier detection algorithms and ready for the experiments. Well, The significant challenge of the outlier detection methods is about the algorithm selection. We are not sure whether the return results are really consistent with the audit objectives or the audit judgments. So in this study, we ask our audit partners to initially identify several obvious outliers in terms of the traditional audit procedures and their judgments. And in our initial run, we try to select the most credible algorithms that can select most of the obvious outliers. Intuitively, if one algorithm can select most of the obvious outliers, this algorithm is really credible in this specific context, which is really consistent with audit judgments and audit objectives. And in the second run, we remove the obvious outliers and only rerun the credible algorithms and try to discover some outliers potentially ignored by our auditors. And finally, we identify such non-obvious but important outliers for follow-up investigation. So this is just the basic idea for this proposed framework. And I just try to briefly discuss the evaluation results. In this evaluation, we basically focus on a revenue subledger dataset from our audit partners, and we perform these two run experiments. In the initial run, we select the credible algorithms, which really make sense in a specific engagement context. And secondly, we rerun the credible algorithms to discover several non-obvious outliers. And finally, according to the feedback of our auditor collaborators, the evaluation result is really favorable, and we really discover several outliers potentially ignored by the auditors. This slide just tries to show you the algorithms we use in this project and the combination of parameter settings. And I just wrap up this presentation very quickly. Basically, we have proposed a framework and try to conduct an experiment with two-run design. And we hope we can really figure out the credible algorithms that are really suitable in a specific context. And finally, we also use this framework to do evaluation, and the result is good. This is basically we have three contributions to the prior audit analytic literature. Firstly, to the best of our knowledge, this is the first research to propose and validate an outlier detection framework that incorporates the choice of credible algorithms and assists the auditors in identifying non-obvious risky observations. By asking our auditors to initially identify obvious outliers, and based on this criteria, we do selected the credible algorithms. This is a very unique advantage for our framework. And secondly, our proposed framework could mitigate bias induced by the algorithm selection. As we discussed beforehand, our framework just try to partially mitigate the challenges of outlier detection application. And finally, to reduce the concern that the unsupervised nature of outlier detection algorithms may impair the outlier score's relevance to specific audit objectives, we really employ a credibility test to identify those outlier detection algorithms that are relatively consistent with auditors' judgments. Okay, this is end of this presentation, and thank you a lot.